Hello, everybody. Welcome to section 1.10. This section is on lines. Last time we talked about graphing basics in general, but now we're going to delve into lines in more detail. So to start, let's look at like a drawing, maybe of a line on a coordinate grid. So our x-axis, our y-axis, and actually let's put some ticks on it. Let's do there we go. And then I'm going to draw a line kind of like this. There we go. Cool. And so there's a couple features of a line that we're going to want to pay attention. So like last time we learned about x and y intercepts. So that would be here would be the x-intercept. Here would be the y-intercept. And the other important feature of a line is its slope. So its slope is how much it's tilting. So slope is how much tilt there is, right? And the way we calculate that is by rise over run. More concretely, if we pick 2 points on the line, say we want to pick like, I don't know, let's do this x1, y1. And then if we pick, I think, 1, 2, 3, 4 up here, this point right here, x2, y2. So if we have 2 points in the line, then we can say that the slope is equal to y2 minus y1 over x2 minus x1. So rise over run. In this line in particular, our points are, this one is 0, 1. And then this one is 1, 2, 3, oops, 2, 3, 4, 1, 2, 3. This one is 4, 3. And so if we were to use this formula to calculate it, y2 would be 3, y1 would be 1, so 3 minus 1 over x2 is 4 minus x1 is 0, which would be 2/4, or more commonly known as 1/2. So for this line up here, slope is 1/2, calculated by using this formula right here. Cool. So if we look at like the slope of lines, there's like 4 common sort of variants that we'll see. So the first one is, or actually let's draw for these bad boys. I cannot space things out to save my life, apparently. There we go. Okay. So if we see a line that looks kind of like this, so pointing up, we say that this has positive slope. If we see a line pointing down like this, then we say it has negative slope. If we have a line that's going straight across like this, so it's parallel to the x-axis, we say that this has 0 slope. And if we see a vertical line parallel to the y-axis, we say that it has no slope. The slope does not exist. Cool. So we kind of know what lines look like when we draw them, but what do they look like when we write down their equations? So that's something we're going to want to know. So let's look at line equations. So the first one we're going to look at is point slope form. For a line that passes through the point x1, y1 with slope m is described by the formula y minus y1 equals m x minus x1. So this is the point slope form of the line that passes through x1, y1 and has a slope m. So slope m is here, and our 2 points are here and here. Cool. Another kind of way of writing down the equation of a line is called slope intercept form. And so if we do a line with this time y-intercept is b and slope m is described by the equation y equals mx plus b. This one's, I think, probably the most famous. So our slope m is here, and our y-intercept b is here. These two are like the most general, the most commonly used forms of a line. There are special cases, though. For horizontal lines, their slope is 0, and you could actually get horizontal line equations by deriving it from these two up here. But for a horizontal line passing through the point, say, AB, the equation for that is always going to look something like y equals b, where this b, again, is the y coordinate of a point the line passes through. And then for vertical lines, passing through AB, then that equation is going to be x equals a, where a, again, is the x coordinate of the point that the line passes through. Okay, a lot of information. One more thing to note. So note that if you have a line of slope m, so if we have a line of slope m, another line is parallel to this line if it has the same slope, right? So, oops, another line is to this line if it has the same slope. Cool. And a line is perpendicular to this line if it has slope -1/m. So another line is to this line if it has slope -1/m. So to see this in drawings, if we have our coordinate grid and we were to draw some line, this green one here, then a parallel line would be the same slope. So the same tilt so that they never cross. Parallel lines, no matter how far out you go, never cross. So we want them to have the same slope. This one is parallel. And then if we draw a line with -1/m slope, we will actually, you'll see that you get a perpendicular line, which is a line that crosses our line at a right angle. So this is perpendicular. Cool. All right, let's talk specifics. Let's look at maybe an example of something we should be doing with lines. So for the graph below, which I will draw in a minute, write the, let's do the line in point slope, oops, and slope intercept form. So let's draw the graph that this refers to. So I'm going to do this coordinate grid, x-axis, y-axis. And I want my line to pass through the points. Let's do 2, -1, so that's here. And 1, -1, so that's here. Or sorry, -1, 1. There we go. And so that line, something like this. All right, so I want to do point slope and slope intercept form. So let's first, because we actually need it for both of them. First, let's find the slope. So remember, it's rise over 1, and the equation was y2 minus y1 over x2 minus x1. And it doesn't really matter which point I pick to be my x1, y1, and which point I pick to be my x2, y2, as long as I'm consistent between the two of them. So for this one, I think let's do y2. I'm going to make this one the second point, this one the first point. So y2 is going to be -1 minus y1 is 1 over x2 is 2 minus x1 is -1. So then this becomes -2 over 3. Minus -1 is +1. And so this becomes -2/3. So that's the slope. So actually with this, we can write down our point slope form. Because now we have a slope and we have a point. So remember, it's y minus y1 equals x minus x1. And so in this case, we would do y minus y1 is 1 equals m is -2/3. And then x minus x1 is -1, so this would be +1. Cool. Now, we could have picked the other point, so it is perfectly okay to use the other point. So in this case, I would use, for y1, I would use from this point, -1, so that'd be +1 equals, the slope stays the same though. And we have x minus x from this point, which is 2. Groovy. So actually, if you were to expand these out and use the math, you could actually get from one to the other. They're both perfectly acceptable, perfectly correct answers. So it doesn't really matter which point you use. Cool. So that was point slope form, but next we need to do slope intercept form. So now we need y-intercept. And if you remember from our previous section, to find the y-intercept, we can actually use these equations we came up with, and we're going to set x equal to 0. So I'm going to pick this one, y1 equals -2, 3, x plus 1. I'm going to set x equals to 0. And so I'll get y minus 1 equals -2/3. 0 goes away, so it's just times 1. So that's just -2/3. And then if I add 1 to both sides, oops, I get y equals 1. -2/3 plus 1 is just going to be 1/3. So that is the y-coordinate of y-intercept. So our y-intercept is 0, 1/3. So then if we write this in slope-intercept form, we get y equals, our slope again was negative 2/3 from above, x plus now our b is the y-intercept, and that's going to be 1/3. Cool. So our two answers for this question are going to be our slope-intercept form and our either one of these point-slope forms. Cool. So that's how we deal with lines. Keep working on the homework, and I hope to see you in office hours.